Welcome to our CIT 325 Week 4 presentation by Deanna Squire and Dana Herdlick. Iterative control structures in PL/SQL are also known as loops. Loops let you execute the same code repeatedly. Choosing the best construct for your particular requirement will keep your code lines minimal, easier to understand and maintain.
A simple loop, or basic loop in PL/SQL, works well when you are unable to find an easier solution for a more detailed structure. There are two kinds of simple loops: guard on entry loops and guard on exit loops. A guard on entry loop will not allow entry to the loop until certain criteria are met. For example, a user must enter a number for the loop to run. Without this user input, the loop would have nothing to use for incrementing. A guard on exit loop has its exit criteria at the end of the loop. This is handy when the attribute is already declared and you just need to run the loop. I have an example of this here on the next slide. Here you can see that the attribute num is equal to the number 5. The loop starts by outputting the line inside value num equals 5, and then loops through, subtracting 1 from the previous number until it reaches 0. That criteria of it reaching 0 then forces the loop to exit.
Loops are powerful yet simple to use. They manage the index and exit as part of the statement definition. There are two types of loops: the range or numeric for loop and the cursor for loop. The range for loop is used when you know the starting and ending points for the loop. The range itself can be integers. The range index can be any identifier. Typically, we use a lowercase I for index or iterator. The reverse keyword decrements from the top to the bottom of the range. Loops always increment by 1. Entry guard implicitly places the exit at the top of the loop. A cursor for loop is ideal when querying a database, table, or view. It can be static or dynamic. Dynamic cursor for loops rely on local scope access using local variables in their select statement. Cursor for loops manage opening and closing of the cursor, fetching records, and exiting the loop when all records are read. There is one caution: avoid implicit cursors in production code. It's recommended explicitly define cursors in the declaration block because implicit cursors in production code do not support formal parameter lists. Here's an example of the syntax for both range or numeric for loops and cursor loops. This shows a for loop in action. The loop iterates through the list beginning at the first index in local variable list using the count function until it reaches the last index and continues through each index. The loop iterates through the LV list from index 1 through 5 using the count function and returning in the statement I is, and it shows the value of the index and the value of the name from the LV list. And you can see that the names are in green, 1, 2, 3, 4, 5, and it pulls from the loop in each one of the indexes, 1 through 5.
A while loop is similar to a simple loop, only it will always start with a guard on entry condition in the form of a true or false comparison. This allows you to use a loop when you aren't quite sure how many times the loop should or will run. For example, in this code, the user wants to see the sum of the increments at the end of the loop. We have set the constraint to be less than 10 so that the loop stops when that is false. After it stops, the sum is shown to the user, as you can see in the results on the right.
Iterative control structures play an important role in making our code readable and portable. By understanding the differences between the types of loops and when we use them, we can create easy to understand and maintain codes. Thanks for joining us today. See you next week.